Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions, the mystery of the Fermi Paradox. If aliens exist, where are they? Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when the conversation turned to a cartoon about flying saucers. Fermi did some quick mental calculations and asked a question that has never been satisfactorily answered. Where is everybody? The universe is approximately 13.8 billion years old. It contains an estimated 400 billion stars in our galaxy alone, and at least 40 billion Earth-sized planets in habitable zones. By even conservative estimates, intelligent life should have had enough time to arise, develop technology, and colonize the entire galaxy many times over. Signals, probes, or artifacts of alien civilizations should be everywhere. But we see nothing, we hear nothing, we detect nothing. The universe appears to be profoundly silent. This silence is one of the most profound and disturbing puzzles in science. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from T. Predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding the Fermi Paradox. If aliens exist, where are they? Is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Drake equation, formulated by astronomer Frank Drake in 1961, provides a framework for estimating the number of communicating civilizations in the galaxy. Depending on the values assigned to its variables, rate of star formation, fraction with planets, fraction with life, fraction with intelligence, etc. Estimates range from less than one civilization, we may be alone, to millions. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes, but as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the discovery of exoplanets has dramatically changed the Fermi Paradox calculus. The Kepler and TESS missions have confirmed that Earth-sized planets in habitable zones are common. There are approximately 40 billion such planets in our galaxy alone. The FP, fraction of stars with planets, term in the Drake equation, is now known to be close to 1. Now, a skeptic might propose an alternative explanation for this. And that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine the Great Filter hypothesis, proposed by economist Robin Hanson, suggests that some step in the development from simple chemistry to interstellar civilization is extraordinarily unlikely, so unlikely that it filters out almost all potential civilizations. The critical question is whether the Great Filter is behind us, we are already past the hard step, or ahead of us, civilizations don't survive to become interstellar. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, proposes that the universe is silent because all advanced civilizations conclude that announcing their existence is dangerous. Any civilization that detects another will destroy it preemptively to eliminate a potential rival. All civilizations that survive learn to hide. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the rare Earth hypothesis proposes that complex multicellular life, and especially intelligent life, requires an extraordinary combination of conditions: a specific type of star, the right position in the galaxy, a large moon, a protective large outer planet like Jupiter, plate tectonics, and others. If complex life is extremely rare, the silence makes sense. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. Recent astrobiology research has identified the characteristics that make Earth unusual. Our moon stabilizes Earth's axial tilt, preventing extreme climate swings. Jupiter deflects incoming asteroids. Our position in the galactic habitable zone avoids sterilizing radiation from the galactic center. Each factor reduces the estimated number of planets with complex life. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation, and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Fermi Paradox. If aliens exist, where are they? This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that we are among the first intelligent civilizations in the universe, not because intelligence is impossible elsewhere, but because the universe has only recently produced enough heavy elements, carbon, oxygen, nitrogen, for Earth-like planets to form. We are early, not alone. The silence is the silence of a young universe just beginning to produce complex life. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the Great Filter is behind us. Something in our evolutionary history was extraordinarily improbable, possibly the origin of life, or the transition to eukaryotic cells or multicellularity, and that improbable step is why the galaxy is quiet. If so, we may be very nearly alone. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the Great Filter is ahead of us. Technological civilizations reliably destroy themselves within centuries of achieving industrial capacity through nuclear war, environmental collapse, or some other self-terminating process. If so, the silence is a warning about our own future. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Fermi Paradox, if aliens exist, where are they, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the survey of over 1,000 nearby stars by SETI projects using modern radio telescope arrays has detected no repeating, artificial-looking signals, establishing that advanced civilizations are not broadcasting strong, continuous radio signals in our vicinity. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the age of the universe, 13.8 billion years, and the time required for interstellar travel even at sublight speeds, thousands of years between stars, means that a civilization that began expanding even 1 billion years ago could have reached every part of the galaxy. Their absence is conspicuous. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the discovery of extremophilic life on Earth in extreme acid, heat, cold, radiation, and pressure suggests that life is robust and can persist in conditions far outside what was once considered possible, strengthening the expectation that life should be widespread. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Fermi Paradox. If aliens exist, where are they? Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Fermi Paradox has become one of the central questions of the 21st century as our technology for detecting life and signals from space improves. The James Webb Space Telescope is analyzing the atmospheres of exoplanets for biosignatures, chemical signs of life, and may produce results within decades. Breakthrough Listen is conducting the most comprehensive SETI search in history. If we detect life elsewhere, the Fermi Paradox becomes more acute. Where is the advanced life? If we detect nothing even with James Webb, the Great Filter hypothesis becomes harder to avoid. The silence has never been more eloquent. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis. And the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Fermi Paradox. If aliens exist, where are they? From the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Fermi Paradox ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, We hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.